In this video, we'll be learning how to find the domain as well as the equation of any vertical asymptote for rational functions looking like this. f of x equals to ax plus b over cx plus d. Now we'll do this using a couple of examples. So let's get started. As a first example, consider the function f of x equals to 8x plus 5 over 4x minus 12. Now the first thing we do here is determine this function's domain, and the way we do this is we look for any values of x at which the denominator may equal to 0. So to do this, we look at the denominator, which is 4x minus 12, and we equate that to 0. So we write equals to 0. And we now solve this. This leads us to 4x equals to 12, which leads us to x equals to 12 over 4. And finally, that leads us to x equals to 3. Now this value, x equals to 3, is the only value which would lead to the denominator of this function being equal to 0. And remember, denominators cannot equal to 0. In other words, we have just found the value of x for which this function isn't defined. So this function's domain is all real numbers, any number except for 3. And we write this as follows. We write domain equals to all x in R such that x not equal to 3. Now, on top of this, this rational function will also have a vertical asymptote. And its vertical asymptote has an equation. I'll just write vertical asymptote. And its equation is quite simply x equals to 3. And you can go ahead with your graphic calculator to plot the curve y equals to 8x plus 5 over 4x minus 12, and you'll see that at x equals to 3, the entire curve is sort of split into two. And in essence, you can think of it as there being a vertical line at x equals to 3. And this vertical line is known as the vertical asymptote of this function. Its equation is x equals to 3. Now, if you were to do this with your calculator, as I said, you should find a curve looking something like this. And there you go. That's what this function's curve would look like, and how to find its domain as well as the equation of its vertical asymptote. Now let's look at another example. Let's say we're given the function f of x equals to 12x minus 2 over 4x plus 2. Well, in this case, again, our first step is to find this function's domain. And to do that, we equate the denominator to 0, and we solve. So that's 4x plus 2 equals to 0, leading us to 4x equals to minus 2, which leads us to x equals to negative 2 over 4, which is x equals to negative 1/2. Now, again, this is the value of x at which the denominator would equal 0, which can't be done. We cannot divide by 0, so denominators cannot equal to 0. So this function is perfectly well defined for any value of x except negative 1/2. Consequently, we can write its domain as domain equals to all x in R such that x not equal to negative 1/2. And just as in the first example, this leads us to a vertical asymptote, and it has an equation. So vertical asymptote, and its equation is x equals to -1/2. And if you were to draw this on an xy grid with your calculator, you'll see that at x equals to -1/2, the entire curve splits into two separate pieces. So if I were to draw this vertical asymptote here at x equals to -1/2, this somewhat vertical line, then with your calculator you would see that the curve would look something like this. And there you have it. That's how you find the domain and the vertical asymptote of a rational function.